Everything you say can be used against you. In this little code.
They're trying to.
Oh, man. Are you recording?
Yeah.
Oh. Can I stop it for a second?
So
Pause.
No.
they will. I just don't know what they, I don't know anything about it. Other than I had a meeting with them today and they said, do you know a student you can recommend to us?
Thank you.
Here,
Okay.
Because of the, because you switched from GA to 40 staff. So
Oh, is that the, oh, that's here.
they'll pay for your education.
Yeah.
So,
Okay, let's get started.
okay, I need to switch things around here.
Yes, sir.
Okay, so I've got on the big screen, I have your whiteboard up. And then I'm gonna put you up on the small one.
Thank you.
There we go. All right. Guys, you're here.
Are you,
Can we make sure these all get turned off? All right then. Bye-bye.
are you taking off?
Okay.
Have a good night. I'll see you. Tomorrow we have the bachelorette, right? Or what, baccalaureate?
Do what now?
We have the meeting, right, at 9:30? With the
Yeah.
regalia?
Yes, we do.
Okay, I'll be there. I'll see you.
Bye-bye.
Have a good night. So let's get started. So tonight is going to be the last night we are going to be teaching. Jefferson, can you hear me? Oh, they probably can't hear me. Can you hear me? Okay, tonight is our last class, okay? There's no class next Monday. Okay, so like you should all by now should be registered for summer and fall classes, okay? I just want to bring that to your attention. Please make sure you are registered for summer and fall classes. And now here's a question. Somebody brought this to my attention. It escaped my attention somehow. You know, on test 2, there were topics that were not actually covered in class by the time test was assigned. Have you guys noticed that? Somebody said that, like, okay. Oh, we didn't take test 2 yet? Oh, okay. So that's good news then, because then I can adjust the topics to match what is in class, okay? So test 2 and the final are both due, and including the discussion too, right?
Yeah, but I thought the final was going to do next week during class.
Oh, okay, okay. Let's do that then. Thank you. But that gives you more options because the final is online, right? Instead of being class time, it goes all the way to 11:59. You know what I'm saying? So, okay, test 2 and discussion 2 will be due Sunday, May 1st, 11:59 p.m. And the final will be due Monday, 11:59 p.m. Okay? Jefferson, did you hear that? So final will be due Monday, 11:59 p.m. Discussion 2 and test 2 due Sunday, 11:59 p.m. I should have posted test 2 by, I'm going to put a new version that is like more in line with what we teach in class. And that is going to be there by Thursday morning. Please do not forget. Okay, Thursday morning to Sunday, 11:59. That's the window in which you'll be completing test 2. Now, and same with the final. Don't take the final that is there yet. If you have taken it and you aced it, that's fine. You don't have to retake it. But if you have not taken it, I'm going to put a version that says final spring 21, test 221 versions that are like going to help you because, you know, some of the topics I want to check, like, you know, if they are exactly what we covered in class, okay? But if you have already taken them and gotten good grades, you're happy with it, you don't have to take them again, okay? Because I know some of you sent me emails and said because of their schedule, they had to complete stuff early. And they talked to the International Students Coordinator and they were fine with it and stuff, okay? Okie dokie. So let's get started. Tonight we are going to cover chapters 9 and 11. You know, we are not going to cover the entire chapters. We are going to cover topics within the chapters, okay? This chapter 9 is very technical, you know. Of course, normally this class requires you to know calculus, but I'm not going to assume you know calculus. I'm going to give you the forms of the functions, the functional forms, and you can use those as given. You know, you don't have to drive them using calculus. Okay, here are the learning objectives. Now, in chapter 9, we basically study oligopoly models, okay? Oligopoly models. And we study them mathematically. How do oligopoly models maximize profits? And in particular, we are going to study a form of oligopoly called duopoly, meaning there are only two firms in the industry, okay? So what is an oligopoly? Now, oligopoly is an industry structure in which there are a few dominant firms, okay? Usually less than 10. By dominant, we mean these firms are very large relative to the industry. You know, when I say relative to the industry, like they are like altogether, like those 10 firms constitute, let's say, at least 50% of the industry. Okay. Now, when you have oligopolistic models, you know, you have to act strategically because your opponents respond to your price or quantity behavior. Okay. You know, like if you cut prices, they might also cut prices. You cannot assume they're not going to cut prices. Okay. If you raise prices, you probably lose market to them because they might not follow you. They probably won't. Okay. Now, the first model we are going to study as a model for a oligopoly is the Sweezy oligopoly, also known as the kink demand curve oligopoly. Okay. Now, here are the assumptions of this model. In this model, firms are producing differentiated products. In general, in oligopoly, firms could be producing homogeneous or differentiated products. Either could happen, okay? Now, in this model, there is some asymmetry in that when the firms raise prices, the other firms do not respond, but when they cut, they do, okay? So if they reduce prices, if this firm reduces prices, the competitors will also reduce prices. But if you raise prices, they don't follow you. Okay, that's the assumption. Now, when that happens, you get the following demand curve for the firm. Okay, normally, if nobody responded, you know, the demand curve will be for the firm. For the first term will be actually A2, B2, you know, basically where it says demand 1. Okay, so there are two demands basically. Now, when you raise prices, they don't follow you. They don't raise prices. What does that do, in your opinion? If firms don't follow you, you're the only one who's raising prices. What will happen? You lose market. Your demand curve actually is no longer this demand curve. It bends. Okay, it bends. Now, on the other hand, when you lower prices, they cut prices, right? So what will happen? Now, if they hold their prices constant, your demand will continue, right? But since they're also cutting prices, right, you have to compete more with them, okay? So you lose actually potentially market share to a lot of firms, right? So your demand curve becomes kinked here. So you have this green demand curve now. Now, if you have the green demand curve and you're a profit maximizer, right? How does a firm maximize profits? Marginal revenue equals marginal cost. Now, what is the marginal revenue for the demand curve that is green? It is actually discontinuous. Why? Because marginal revenue is this basically for a linear demand curve is twice as steep as the demand curve, right? So for this section of the demand curve, you get the dotted red line, right? But then as the demand curve becomes more negatively sloped, so does your marginal revenue, okay? And at the kink, it'll be discontinuous because all of a sudden, once you move even 1 point to the new demand curve, your marginal revenue drops down, okay? So this firms marginal revenue curve is discontinuous. It's from A to C, jumps down to E, goes to MR, okay? So there's this area where there is indecision. If your marginal cost is between those 2 points, you know, basically you still produce the same output, okay? But price action could be very different depending on your marginal cost, okay? Now, but we are not going to mathematically study this model any further. We're not going to drive like the forms of those functions and so forth, okay? It's just to give you an idea of like, you know, how does an oligopoly in which the price behavior is asymmetric would its actions affect its demand curve, okay? That's the idea. You know, remember, like, what is the market demand curve? Market demand curve is the sum of individual demand curves, okay? So if other firms are stealing from the market demand against you when your price is such or price behavior is such, you'll be losing demand. Your demand curve will literally be shifting to the left. That is why, like, you know, we have this green like shifting backwards, because as the firm cuts prices, it's losing market share, right? Because other firms are responding to it. And there's a lot of other firms, okay? So now Cournot oligopoly. Now Cournot is a different setup. In this case, the product need not be differentiated. It can be homogeneous or differentiated, just like any other oligopoly. Now, but there's a crucial assumption. In this case, the firm believes if it changes its output, other firms will not respond. Okay? If it changes, remember, like with the Sweezy, the action was based on prices. Here, the action is based on output. Okay? If I raise my output, they actually are not going to respond. Okay? Now, of course, for it to be oligopoly, there are some barriers to entry, right? Because otherwise, there'll be like many more firms. Why is that? Well, why are there barriers to entry? Because there are a few dominant firms. How do you dominate an industry? You have to be large. Okay. Now, also, how do you know if a firm is large? Relatively speaking. How do you know if a firm is a price maker, like it affects prices? Oh, you could look at the Hirschman index for the industry, but the individual firm, like, you know, how can you just look at it and say, oh, wow, this firm is large? Okay. You could do that, but also you could just look at its demand. If the demand is negatively sloped, that firm has price control. Remember, for the competitive firm, demand was flat. It was perfectly elastic. It cannot affect prices at all. If it raises its price a little bit, it loses all its market share, okay? So the steepness of the demand curve or the negative slope of the demand curve indicates some price control, okay? Now, how will the Cournot duopoly act, okay? Now, of course, a Cournot duopoly is just a profit maximizer, right? It's just like any other firm. Now, of course, here, why isn't I? Okay. Now, there are a few functions. I'm going to explain all these in detail. The first one is the total market demand. Total market demand. Now, this is the inverse market demand curve, okay? It has intercept A, it has slope B, and the total output in the market, since it's the market demand, is the combined output of the two firms. It's Q1 plus Q2, okay? Remember, like, what is the general form for an inverse demand curve? A minus BQ. But in this case, Q is total Q for the market, and it's the sum of the outputs of individual firms, right? You know, like if one firm is selling 5 at a given price and the other firm is selling 10, together they're selling 15. That's the idea, okay? So basically, output is for a given price, horizontal summation of the quantity is basically added horizontally at every price to get the market demand, okay? So basically, you horizontally add the individual firms' demands to get to the market demand, okay? Now, the second functions you have to pay attention to are the cost functions, okay? Now, if you look at these two cost functions, they're both linear. They're upward sloping, linear. Marginal costs are constant because if you differentiate this, you'll end up with C1 for the first term. And for the second term, you'll end up with C2. So if your marginal cost is constant, so is your average cost, okay? And it's equal to it. So for these firms, the average total cost and the marginal costs are constant and equal to C1 and C2 respectively. Okay. If I were to draw those cost functions for the first firm, it'll look like this. So you will have like, like C1, and then here you will have Q1, and it'll be like this, and the slope of this line will be C1. Okay, that's the slope. Now, there's no intercept, if you notice, and C1 is greater than 0. Okay, it's a positively sloped curve because costs increase if you produce more. Now, the same with the second firm. Now, be careful. This notation, when you say C1, Q1, what does that mean? That doesn't mean you are multiplying C1 and Q1. That means C1 is a function of Q1. Okay? The left-hand side, you read it as C1 depends on Q1. Okay, it's just bringing it to your attention. The cost of the first firm only depends on its own output. It doesn't depend on the second firm's output at all. Okay? Like, what does that imply? In input markets, these firms are small. If one pulls inputs out of the market, it doesn't make it more costly for the other firms to buy the same inputs. Okay? So both firms, although they are large in their own industry, in the industries in which they buy inputs for their cost purposes, like labor, like capital, like entrepreneurship, like land, they are too small relative to those markets. Like, because if I was a giant firm, right, I was like vacuuming basically 60% of the labor. The price of labor would go up for the other firm. So their cost will depend on my output. Okay? The fact that the cost for the first firm depends only on its own output indicates in the markets in which it operates to buy its inputs, it's a small firm. But in the market in which it sells output, of course, it's a large firm because it's an oligopoly. In this case, actually, it's part of a duopoly. It's one of two firms. And for Kurno, we are going to assume both firms are the same size. They own 50% of the market. Okay? Of course, here we have not assumed that yet. For that to happen, it's kind of the cost will have to be symmetric. They will both have to be like C1 and C2 will have to be equal. Okay? But eventually, we will assume that. Now, if you look at this, you see these reaction functions. Those are the profit maximizing quantities for firm 1 and firm 2 respectively. Okay? That's the, like in mathematics, you have that term, loci, locus versus loci. Does anybody remember? Loci means locations of profit maximizing quantity for each firm. Okay? Now, if you draw that on a graph with Q2 on the vertical axis and Q1 on the horizontal axis, and if you look at this, actually, let's look at the format of these functions, right? Remember, Q2 is on the vertical axis, right? And usually we write when we write a function, the vertical axis variable is the left-hand side variable. It's just convention. So look at this function, right? These are all constants. A is a constant. What was A? Intercept for the market demand, right? Remember, because market demand, if you go back, oops, I went too much. Look at here. It's the intercept for market demand. It's the intercept for the inverse market demand because price is a function of quantity. Okay? So now B, on the other hand, is the slope of the inverse market demand. Okay? So let's go back, look at the functions. Oh, wow. Did my pictures disappear? No. Okay, for a second, I thought they disappeared. Okay, so look at this. What is A? A is the intercept for the inverse market demand. What is C1? C1 is the marginal cost and the average total cost for the first firm. Of course, let's look at the second one, because since we are writing that on the vertical axis. So this is the marginal cost and the average total cost for the second firm. And what is B? B is the slope of the inverse demand function. Now, so you're taking basically, but together, what are they making up? They're making up the intercept for what? The reaction function for the second firm. And what is the reaction function for the second firm? It's the location of profit maximizing quantities for firm 2 as a function of the output of the first firm. If the first firm's output was given, right? What should I produce to make maximum profit? That's what that function is telling you. Okay? So if Q1 was given at, let's say, 10, right? I'll literally plug 10 in here, and given all these fixed constants, I'll literally automatically know what's the profit maximizing quantity for me to produce, okay? And what is the assumption? If I change my output, they're not going to in turn respond. But is that assumption correct? No, because they'll actually change their output based on yours. If you change yours, they'll respond to it, okay? So the firm has an unrealistic assumption. Okay, so if you draw those two functions, there is only one point that is compatible with profit maximization by both firms. It's the equilibrium point where the two intersect. So if you took these two functions in two unknowns, solve them together for the equilibrium Q1 and Q2, that'll be the Cournot equilibrium. In this graph, it happens at Q2 Cournot and Q1 Cournot where the two reaction functions intersect. So that is the mutually profit maximizing stable equilibrium for both firms. They don't have an incentive to diverge from it, okay? Because if one did, the other will respond to pull it back, okay? Now, that's what it's saying, like, neither firm has an incentive to diverge from the equilibrium one is established, because otherwise they'll be reducing their profitability. Why is that? Let's look at the ISO profit curves. Now, if you went ahead and computed profit, right? And remember, what is profit? Profit is total revenue minus total cost, right? So you know the profit maximizing quantity for the first firm, right? And given the outputs of those two firms, you can use the demand curve to compute actually the profits for either curve, right? Firm. Now, if you do that, you'll realize as functions of Q1 and Q2, those profit curves, profit functions will be nonlinear. They'll be curved, okay? And not only that, since the reaction functions are the locations of maximum profits, those maximum profits will happen actually on the ISO profit lines. And in particular, they'll increase as the output of the individual firm increases. Why is that? Because remember, at this point, why is profit at a maximum? Why is profit of the first firm at a maximum at Q1M? Exactly. Q2 produces nothing. They have the whole market to themselves. If the other firm is producing nothing, what do you become? Monopoly. That's why it's called Q1M. Okay? When you are the monopoly, you have the entire market to yourself. You make the maximum profit. What is the other extreme? You're producing nothing. The other firm is producing everything, right? At this point, actually, the other firm's profits are maximized. Okay? So, or somewhere in there, kind of. Now, if you draw both of these profit curves on the same graph, right? At the equilibrium point, the two profit curves kind of intersect, and those are the Cournot profits for each firm, okay? Now, firms don't have an incentive to diverge because as they diverge and the other firm reacts, their profits will be lower than at the equilibrium. Okay, we can prove that. We can prove that like graphically, you can prove that using calculus, okay? Now what happens if a firm's costs decrease, right? Let's say the second firm's marginal cost and average total cost in this case decreases. What will happen? Now let's go back and look at the reaction functions. Because remember, the marginal cost and the average total cost, the same thing in this case because we are assuming the cost functions are linear. Enter the reaction functions, the location of profit maximizing outputs, right? Look at this. If you change C2, right, make it lower or larger, what will you be doing to the reaction function of the second firm? You won't be affecting the reaction function of the first firm at all because C2 is not in there. But what will you be doing to the reaction function of the second firm? You're changing the intercept or shifting it parallel to itself, okay? So, and if you go back, you'll see that in that graph. That's why, because if you look at the form of the reaction function, you realize C enters as part of the intercept for firm 2, okay? So let's go here. See, like if the marginal cost goes down, its reaction function will actually shift up because remember, it's entering as minus C. You know what I'm saying? As it goes down, the intercept will be larger. So it'll shift out. If it shifts out, the equilibrium moves from point E to point F, right? And point F is what? Much more profitable for firm 2, because remember, firm 2's profits move in this direction. Firm 1's profits move in that direction. So basically, as the marginal cost of a firm decreases, its market share increases and its profits increase. It's capturing more of the market relative to this competitor, okay? So in this model, one way these firms can compete against each other is to actually make technological breakthroughs to change their costs, okay? To change their costs. And it doesn't matter if they're producing a differentiated product. It doesn't matter if they're producing a homogeneous product, okay? Because remember, in a sense, we are assuming the demand is kind of common between the two, okay? Now, there is a possibility these firms actually will collude to make even more profits, okay? If they compete against each other under the assumption that when I change my output, the other firm will not respond, they end up with the Cournot equilibrium. But if they become a monopoly and share the output, right, they'll actually make higher profits. Now, the monopoly, the locus of monopoly behavior is actually along this curve. Because at this point, firm 1 is a monopoly. At this point, firm 2 is a monopoly. But they can share the output between each other linearly. Like, for example, in the midpoint, let's say you took exactly the midpoint. Half of the monopoly output is produced by firm 2. Half of the monopoly output will be produced by firm 1. If you move up this graph, like on this dotted line, you'll be making firm 2 produce more of the monopoly output. And if you move down, you'll be making firm 1 produce more of the monopoly output. You know, that's a decision between them. Like, you know, any combination there they could produce, but which combination are they going to produce? That maximizes maximum monopoly profits. And if you compare those points, like look at where the isoprofit curves are touching each other, neither one has an incentive to deviate because they'll end up at a lower monopoly profit. So this is the profit maximizing point, or the combination of Q1 and Q2 for the monopoly profit, okay? This is the best the two firms can do as a monopoly. So where should they share their outputs? Firm 2 should produce Q2 collision, and firm 2 should produce Q1 collision, okay? That's the profit maximizing share. And that is partially a function of their individual marginal cost and so forth, okay? Now, and if you look at those isoprofit, for example, for firm 2, right? Profits increase in this direction. If you go up, as firm 2 becomes a monopoly, right? Now, compare their Cournot profit, Cournot isoprofit, compare it to the collusion isoprofit. The collusion isoprofit is further to the northwest, right? Therefore, it's higher profit. So these firms actually have an incentive to collude. But they also, once they collude, firms have an incentive to cheat, even make their profits higher by kind of themselves becoming a monopoly, okay? Or moving towards a monopoly. So these cartels where these firms collude are not sustainable. Like, you know, OPEC, for example, the oil cartel worldwide is not sustainable because remember, monopoly gets the best price, right? If you cheat it, you don't affect the market as much because you are part of the market, like you're a 10th, 20th of the market, right? So if you increase your output, you don't make price raise too much if others don't respond to it, right? But you sell that extra output at that really high price, almost the same price, right? Because since you're a small portion of the entire market, it'll be very profitable for you to cheat, okay? But of course, there has to be a monitoring mechanism, you know, which is kind of hard, right? With oil, like, you know, like a lot of countries actually sell oil on like underground markets and stuff, like, you know, you have to be literally following their tankers and stuff, like, you know, okay? So that's why like OPEC always fails to collude, like, you know, they can never charge the best price. They always compete against each other, okay? It's because, yes, monopoly profits are higher, which we call cartel in this case. Cartel is when like firms get together to act like monopoly, you know, but cheating profits are even higher. But if everybody cheats, what do you end up with? You end up with Cournot, okay? Any questions? Now, Stackelberg is similar to Cournot, but there's a slight difference. In Stackelberg, there's a leader firm that sets its output and the follower firm follows whatever output it sets, okay? So basically, the leader firm takes the profit maximization problem of the follower and puts it inside its own profit maximization and solves for the maximum profit, okay? Gets the best possible scenario. And once it produces that output, the follower firm just takes it as given, okay? Whatever it dictates. In that case, the Stackelberg firm will capture more of the market and make higher profits relative to Cournot. And the follower firm will make lower profits relative to Cournot because they'll have a lower share of the market, okay? You know, Stackelberg applies to a scenario where there's already an established firm, you know, and the new entrant or new kind of oligopolist follows it, okay? Or like it could be like Intel versus AMD. Intel owns 90% of the market, dictates like everything, and then AMD basically follows them. Okay, so mathematically, if you solve the problems as I just mentioned, you'll end up with a reaction function for the leader, that is this, and the first one will take that as given and then solve its own problem, and then it'll end up with this reaction function. Now, if you solve those two together, you'll actually end up with this graph. Okay. No, the second one is not the same. The first one is the same. Remember, like the first firm's the second one is the same. The first one is not the same. The first firm basically does not have its output is not, it's completely parametrical. It doesn't have any, it doesn't react to the second firm's output at all. It's optimal, it's just a point, okay? It's not a function, basically, or it's a constant function, basically, okay? None of these is like, there's no Q1. Sorry, there's no Q2. There's no Q2. Now, here's an example, you know, like you can basically plug in all the numbers and solve all for all those. It'll be redundant for me to just repeat it. Now, the final oligopoly model we are going to study is Bertrand. In Bertrand, we have a situation similar to the previous case of Cournot, but the competition or the decision variable is not, competition is not over quantity, it's over price. It's over price. The decision variable is price. You know, like the firm is assuming if I cut costs, the other firm won't respond. Remember, like in the quantity case in Cournot, the firm was assuming if I increase quantity, the other firm won't respond. Okay, if I change my quantity, the other firm won't respond. Here, the firm is assuming if I change my price, the other firm won't respond. Okay, now, of course, we know, right? If I cut my prices, what's going to happen to the profits of the other firm? They're going to lose all their market to me, right? You know, because if the product is homogeneous, right? Even if I cut my price by 5 cents, right? The second firm, if it's the same exact firm as me, like size-wise, cost-wise, everything, what's going to happen? They're going to lose their entire market share. I'm going to own the entire market. I become a monopoly, right? They're not going to sit there, watch me like act like a monopoly, right? They also cut prices. But if you walk down that ladder, where do you end up? You end up at marginal cost. You end up at competition. You make zero profits. Go ahead, sorry. Exactly, no profits. Well said. You know, basically, in Bertrand, firms cannot make profits at all. It's as though like they're perfectly competitive. Although there are only 2 firms that dominate the markets, far from competition, right? The situation. But since they're competing on prices, they cut their prices all the way down to marginal cost. Now, the reaction functions for Bertrand are not linear, like the Stackelberg or the Cournot. They're actually like weirdly shaped functions, okay? They have kinks in them. They're linear in ranges, like, you know, they change slope, okay? They have kinks in them. But the important thing to remember is, in this market, if marginal costs were the same, the prices will basically be equal to that marginal cost in equilibrium. These firms will not be able to make any profit at all, okay? Now, here's an example comparing different oligopoly models. Basically, you plug in all those numbers and collusion. Now, this is it for chapter 9, and then I'm going to go to chapter 11. Any questions? all you have to do is basically for these type of questions, pick up the basically parameters that are given to you and plug it into the given functions, reaction functions. Once you find the two quantities, right, what do you do next? You go to the market demand to find the price, inverse price, right? Once you find the market price, and you know the, actually, let me talk about a little bit about that because that's going to be confusing for you. Let me cover that. Oh. Okay, so I have this inverse demand function, right? Price equals A. Oh, that's supposed to be an equal sign. It's not a Z. Okay, A minus B times Q1 plus Q2, right? Everybody agrees, right? That's my inverse demand function. Now, what do? I have the reaction functions, right? I can solve the reaction functions together, right? It's two functions in two unknowns. What will that give me? That'll give me the intersection of the reaction functions. At the intersection of those two reaction functions, this is Q2, this is Q1. What do I have? I have Q1 Cournot, which is basically an equilibrium point, and I have Q2 Cournot. Once I solve those are just numbers. Let's say this is 3 and this is also 3. I'm just making them up, right? And let's say A is equal to 10 and this is equal to 0.5. Okay? Now, once I have these, I can plug them back in. My price will be 10 minus 0.5 times 3 plus 3. Okay? So it'll be 10 minus 0.5 times 6, right? So it'll be 10 minus 3. My equilibrium price is 7. Both firms will be selling their output at 7, right? Now, I can use this, and also remember, let's say the cost for the first company is equal to some constant, right? It's equal to like, let's say 2. And it's the same for the second one. Let's assume like their costs are symmetric, okay? Okay, so now I can now compute their profits, everything I want, okay? So remember, price is equal to what? 7. So profits for the first firm is equal to total revenue of the first firm minus total cost of the first firm, okay? Now, remember, this is just price times quantity, Q1, and this is equal to C, which is in this case 2, of course, C1 times Q1. This is 2. In this case, I just assume that when you solve the reaction functions together, they each give you 3. Of course, please forgive me. You know, if you really actually solve them, they probably won't give you 3. Okay? But I'm just illustrating the point. Don't say he doesn't know his algebra. Okay? So this will be price. What is price? 7 times 3, right? Minus C1, which is 2 times 7. So that'll be basically just 7. So what is the profit of the first firm? 7. Since they are symmetric in costs and everything, the second firm will also have profit 7. Okay? I just want to illustrate that, like, you know, when you do this like in Managerial Connect, now you are more familiar with like what kind of setup you could expect, okay? And to get the reaction functions to solve them together, you literally have to plug in the numbers or the parameters they're giving you. And then how many of you know like how to solve 2 equations in 2 unknowns? Okay. So let me give you an example, like, you know, oh, that didn't work well. Force of habit. Okay. So let me go back here. Let's give these some numbers and help you like see like how this can be solved together. Okay, so I'm given A, right? And in the previous example, what was A? A was 10, right? What was B? B was 0.5, right? Now, okay, So I can write Q1 equals, what is my A? 10 minus C1. What was C1? 2 divided by 2 times 0.5 minus 0.5 times Q2. Okay, so what is this? This is the reaction function for the first one. That is the basically combination of quantity pairs that maximize profit for the first one. Okay, so whatever they produce, if I see what they produce, I produce this, I maximize my profits. Okay, so 10 minus 2 is 8, right? Divided by 1 is 8. So this will be 8 minus 0.5 Q2. So Q1's reaction function is this, right? Since they're symmetric, the second form will have the same format. So this will be Q2 equals 8 minus 0.5 times Q1. Okay? Then you can take this and plug it in here. So 8 minus 0.5 Q2, okay? Of course, actually in here, you could put literally, so this is basically Q1, right? You could do it either way you want. So for Q2, you could put 8 minus 0.5 Q1. Everybody follows? Let me actually erase that. I don't know why I put that there. Okay, so, okay. Uh-oh, that didn't go well. Where did I go? Okay. Man. Okay, so Q1 equals 8 minus 0.5 times 8 minus 0.5 Q1, right? So this becomes 8 minus 0.5 times 8, which is 4, right? Plus 0.5 times 0.5, and that is 0.25 Q1, basically. And remember, that's equal to Q1. Now I can put all my Q1s to one side. If I subtract 0.5 Q1 from either side, this will be 0.75 Q1 equals 4. Okay? 0.75 is, remember, 3 over 4. You multiply this side by 4 over 3, your Q1 will be 16 over 3. And the same will be true for the other side, for Q2, because they're symmetric. Okay? So this is just illustrating how you will solve actually the Cournot outputs. Remember, like I gave it in the previous example, I was just making it up. If you actually solve it, it's not equal to 2. It is equal to 16 over 3. The correct number was this. But why did I do that? You know, because I was just trying to illustrate like how you will actually compute the profits, right? But in reality, if you were giving all that information, the first thing you have to do is to compute these and then plug them back into the demand function. Of course, these are not as nice numbers as the one I put. Okay, so everybody follows everything? Okay, we are done with chapter 9. Let's go to chapter 11. Okay, now in chapter 11, we are looking at pricing strategies for firms with market power. Okay, basically things like price discrimination. You know, like companies like Comcast, Time Warner, they're like basically in their smaller markets are monopolies almost, or near monopolies, right? So they have a lot of ability to actually charge you exorbitant prices. Okay, I actually usually start like this chapters like this, asking my students, what is the maximum you will pay for cable TV? Back in the day, it was different. Like, you know, you didn't have things like streaming services and stuff. When I asked some students, they will say like $600. It was almost like an auction. You know, Time Warner, like, you know, what is the final price? $600. I don't think anybody today will pay $600. I don't know. Some people might. I don't know. If that was the only choice. But today it's not the only choice. So I don't know. I don't judge people. They like cable TV, they like cable TV. Okay. So now, how do firms who maximize profits, right, determine what optimal prices to charge? Okay. Now, here's an equation for a firm that has elasticity EF. That's the elasticity of the firm. What if this firm knows its elasticity or knows the elasticity of a firm similar to it in the industry? What price, given its elasticity, should it charge to maximize profits? Okay. Now that depends on, and remember, what is the profit max? This is a firm, right? Its behavior is going to be determined by marginal revenue equals marginal cost, right? Now, the right-hand side of this equation is marginal revenue. You can show the relationship between marginal revenue and elasticity, algebraically as P times this markup factor, okay? So this is the profit maximization equation, right? The only thing that's left for the firm, once it knows its marginal cost and its elasticity, is to literally compute price, okay? And if you do the algebra, price will be equal to the inverse of the markup factor times marginal cost. Whatever your marginal cost is, and a lot of times, if the firm is buying its inputs in an industry, it could just take that as its marginal cost. Like let's say to get the last 5 units of input, actually last unit of input, I should say, I spent $20. That's my marginal cost. Okay. Now, here's a question. What do you think the marginal cost of Comcast is? To make one more cable TV subscription, right? How much does it cost them? Nothing, right? In a competitive market, what should their price be? Zero, basically, almost. A few dollars. That just shows they're not competitive at all. They're charging people like over $100 for the service, which actually in marginal cost them nothing, right? Now, why is that? Although the marginal cost is very small, it's the elasticity. You know what I'm saying? Their demand is inelastic, in a sense, like they have a lot of control over the customer. You know what I'm saying? Like, especially like internet service provision, right? Forget about the content. Content, they have some competition. You could go with like streaming media service providers, and those are even increasing, right? But with delivery of services, you don't have as much of a choice. And not only that, the new competitors also have high marginal costs. Like 5G, you have to build the network. You know what I'm saying? And that even depends on Comcast network, because at the end of the day, it has to be fiber. Okay. So still, Comcast has a lot of control, insanely a lot. Okay. So what price should a firm in a market charge? It's like inverse of the markup factor times its marginal cost. Okay. Even if it doesn't directly it knows its demand. It could compute its elasticity from demand, or it could just look up like statistics for a firm its size. And these are published, because people do research on industries, and it could just put that in there, impute that in there, and given its marginal cost, it could just automatically compute what is the profit maximizing price. Now, this is just for one firm doing some simple pricing, finding profit maximizing price. If you do this, for example, here's the marginal cost, here's the inverse of the markup factor. This firm, if it maximizes profit, should charge 5/3, basically 1.67, almost rounded up. Now, what if there are like n firms in a Cournot oligopoly? In that case, what happens? In that case, the individual firms' demand relative to the industry is much more elastic. Remember, there are like n other firms that it's competing against. It's like now we are moving towards competition. It's not like Comcast all by itself or like a few firms competing with it. In here, like, of course, n could have been just 2. You'll have a duopoly. But like if you have like many firms, right? If N is really large, your elasticity relative to the market is very high. Remember, like the competitive firms' market demand is inversely sloped, but the individual firm's demand is like flat. Okay, so this is kind of making that point. In that case, the inverse of the markup factor works against the firm. The price is going to be much lower. Okay, it can't put much markup at all. So that's how a firm that competes against N Cournot oligopolies in a market will charge, find the profit maximizing price basically. Now, these are just single price models. There are actually more interesting behaviors. Like there's this concept of price discrimination. If I ask somebody, right, what is the maximum they will pay for cable TV, right? Just to have cable TV. That is basically, I'm extracting all their consumer surplus. Like it's like a measure of how much they're willing to give just to keep it, right? Now there's that first degree price discrimination concept in which like you literally extract all the consumer surplus. Remember, consumer surplus is this upper triangle. This is producer surplus. This is consumer surplus. If you can add all of the consumer surplus to your profit, you end up like with profit, which is this blue area. That's the maximum possible profit you could make. Okay. Now the difference between price and marginal cost at each point, that is your profit. Okay, that's your profit for that unit. Because the last unit you sold here costed this much, or the first unit, because you're starting at the first one, right? And how much did you charge for it? Almost 10. How much did it cost you? Let's say $1, right? So the profit on the first unit, how much did you make? $9. On the second unit, it cost you a little more, right? Because your costs are going up, your extra cost. But how much did you charge? To convince the person to buy one more unit, you had to lower the price a little bit. It cost you a little bit more to produce. Let's say on that you made $8. So on the first unit you made 9. On the second you made 8. Altogether you have $17. If you keep completing this triangle, your profit will cease to exist here, like for the last unit. It'll be 0, but you'll be making positive profit for all the previous units. And if you add that difference between basically the demand curve and marginal cost, or find that area of that triangle, you'll be finding the maximum possible profit. Now, this is a dream for any firm. Most firms cannot do this, right? Why? Because number one, they will have to have a good idea of what the consumer's thinking is, individual demand is, right? So they have to do some averaging, because if you have a lot of customers, it's hard to know what people think. But remember, like those reward cards that they give you, that's a way to read your mind, to find your demand, okay? So they can use that to at least extract some of that consumer surplus, okay? People think, oh, I'm saving money shopping. But you shop a lot more, number one. Number two, they exactly know what you like by shopping. You know what I'm saying? And your elasticity is measured kind of how you respond to discounts. You know what I'm saying? Or like product combinations. Like they do all kinds of stuff, It's very interesting. Now, second degree price discrimination is not as good as first degree. They don't extract all the surplus, but they extract it in stages, okay? For example, for the first 10 units, you get a price, fixed price. If you want to buy, it's the tiered price, basically. If you want like more channels added, let's say to your Comcast, like you pay a lower price up to like a certain number of channels. And then if you want even more, you get a discount to extract even more surplus from you, okay? So like they cannot get, the only surplus you're left with is like the white areas. That's a measure of like, like remember, like you say, how good a deal am I getting, right? Like when you buy something, right? Like if I ask the students, like, how much would you have paid for your subscription? They say like $500, right? But how much did you end up paying for it actually? $150. So $350 is your consumer surplus. It's a measure of the deal you are getting, right? So here, you have not lost all the deal. They didn't charge you $600. How much did they charge you in these tiers? They got this much from you, this much in consumer surplus for the first one. They got it for this. They got a little bit on this one because the consumer surplus is above the area, above the market price and below the demand curve. So they extracted some surplus, but not all. Okay, so second degree price discrimination for the firm is not as profitable as first degree price discrimination, but still it's very profitable. Okay, that's why they give you like tiered pricing. Like, they say, oh, like if you bundle these two together, add these up, we'll give you like a discount on that individually. But they still make a profit on it, right? Because it costs them less in marginal cost. Their marginal cost is here, like, when they sell you that. Okay, they're still extracting profits from you. Third degree price discrimination is like when you actually create different segments in the market, or use the elasticity of different segments to make profit. Like old people, senior citizens at a movie theater might get a discount. Okay, they might get a discount traveling, like, they might get a discount at the airport and so forth, like buying tickets. Okay, so that's third degree price discrimination. You're not charging the same customer individual prices or different prices. You're charging different customers different prices. That's another way to maximize profits. Now, how do you determine which segment of the market to charge what price? What is different between those segments? It's their elasticity. Remember the single price elasticity rule? What do? You charge a price with the markup factor. The left-hand side is your marginal revenue for the first person. And then you equate that to your marginal cost, right? Your marginal cost is the same. If you're a movie theater, a senior citizen occupies one seat, a child occupies, or a young person occupies one seat. The marginal cost is exactly the same. The amount of, like stuff, let's say they eat popcorn and you have to clean after them. Arguably, it's the same, right? So your marginal cost is the same for both. What is different between them? Elasticities are different. Since the right-hand sides are the same, if the elasticities are different, you will have to make the prices different to maximize profit, because these are individual profit maximization conditions. What is the first equation? Let me ask you. What is the first equation in this case? Jefferson, can you hear the question? What is this first equation? This first equation is what? What is the left-hand side of the first equation? Marginal revenue for the first customer, first group. And this is the marginal revenue for the second group. The right-hand side is marginal cost. Marginal revenue equals marginal cost. What is that equation for? Maximizing profit. So this is the profit maximization condition for the first type of customer. This is the profit maximization condition for the second type of customer, right? Now, prices are definitely going to be different between these two customers, right? Why? Because the right-hand sides are the same, because the marginal cost is the same, but elasticities are different. To make the two sides equal, right? If you have different markups, you're going to charge different prices to maximize profit. Okay? So how do you find your prices? You basically take the inverse of the markup factor and multiply it by marginal cost. Okay? Basically, you divide both sides through by the markup factor. Okay? It's the exact same rule as before, but now you have two types of elasticities. Why? Because you have two different types of customers. Now, here's an example. Now, sometimes there is this two-part pricing. Two-part pricing is when, like, you go to like Costco. They charge you a fee to be able to buy the good, and then they charge you whatever prices or expenditures you make at the business, with the business. Okay. Now, like, it's kind of like a subscription allows you to be able to do business with the firm. Okay. Now, what is the maximum fee they should charge? They could charge. That's a $64 million question. What is the maximum fee this firm could charge? It'll be your consumer surplus, right? That'll make it equivalent to first degree price discrimination. It'll be a different method of first degree price discrimination. That's why I was asking students, what is the maximum you were willing to pay, right? Like, basically, if they're paying that $500, if that's their maximum, and after that, the marginal cost is basically zero, right? You charge them zero, you charge them nothing. So you'll have extracted all their consumer surplus. I think that's it basically. And then there's bundling. You know, you put different products together to maximize profits. Okay. Okay. There's peak load pricing. You know, like at different times of the day, you charge different prices because your profitability changes between different parts of the day. Okay. That's basically it for tonight. So please complete all your work, test 2 and discussion post 2 by Sunday, 11:59 p.m. And then complete your final exam by Monday, 11:59 p.m. Okay? And there's nothing else. Yeah. Yes. Thank you. Those are due Sunday too. Yes. Thank you for asking. That's a very important question. Don't forget your homework's due for Sunday, 11:59 too. For chapters 9 and 11. It's a lot, but you know, it's the end of the semester. There's good news. So next week we don't meet. This is the last day, okay? Any questions? No. Okay, good luck everybody. You all take care. No. No chapter 6. Don't complete that. Yes, midnight Sunday. Homeworks are due midnight Sunday. Any questions, Jefferson? Okay, have a good day. Okay. Oh, you know what? Hold on. Let's take roll. I forgot the most important part because they're going to ask that on your attendance. You know, one of the questions, can we stop this recording?